Use a linear model to make predictions. Now, a linear model is generally talked about in a y equals mx plus b called slope-intercept form. And we do this because this allows us to identify important information from context and then put it in an equation that would allow us to graph it, make predictions, or use anything else with this linear form. Now, when we have an equation in slope-intercept form, it's important to remember that m is the slope, and slope is the constant change over time. So something that happens again and again and again and is consistent. B is our y-intercept. Generally, our y-intercept is when time equals 0, or it's our initial value, also sometimes known as our starting point. So those are all of the ways that I talk about y-intercept. So let's go ahead and play with these. A new runner can run half a mile without stopping, and each week adds 0.15 miles to the distance. Use the model y equals 0.15x plus 0.5 to predict the distance the runner will run without stopping during week 12. Now you'll notice the slope is 0.15 because that's the constant change, right? Each week we add on. And the initial value is 0.5, that's how much we started with. So we have the y equals 0.15x plus 0.5. Now, in this case, x is time, right? Generally, our independent variable is time, which in this case is the number of weeks, whereas y is what we're trying to find, which is the total miles. So in this case, we know week 12 is what we care about. So that means x equals 12. So in my equation, y equals 0.15 times 12 plus 0.5. Now we solve with, order of operations. So we're going to multiply first. 0.15 times 12 is 1.8, and then we still have our half mile there at the end. When I add those two together, I end up with y equals 2.3 miles. So if this runner continues at this pace in week 12, this runner will run 2.3 miles without stopping. And this is the purpose of linear models, that we can use them to predict future information based on a constant change over time. Let's do one more. A jar of flour starts with 8 cups of flour. Each batch of dog treats made requires half cup of flour. Use the model y equals -1/2 x plus 8 to determine how much flour remains after making 6 batches of dog treats. Now here you'll notice that the slope is -1/2 because we use that flour and it goes away. So because it decreases, we have a negative change over time. And 8 is how much flour we start with. So we are using the y equals -1/2 x plus 8. I think it's important to recognize the values of x and y. So x is the number of batches of dog treats. And if you struggle determining this, think about what the slope represents, right? This is half of a cup of flour per batch, right? Each batch. That means x is the number of batches that we're making. Okay? All right, so then y is the remaining or the total flour. How much do we have left? Okay, so it tells us 6 batches, so we know x equals 6. Let's substitute that into our equation. So y equals -1/2 6 plus 8. Again, order of operations. So -1/2 times 6 is 3. So y equals -3, because negative times a positive is a negative. So y equals -3 plus 8, and when I add those together, I end up with 5. So we would have 5 cups of flour remaining after making 6 batches of dog treats. Now, one thing that I do want to throw out with this is that if you struggle with using these models, sometimes just with the context of the questions, you can use, I call it just common sense to figure out the answer. So don't freeze up and think, how do I do this? Just use your life happenings and life skills to work through the material to figure it out. You know, you're using half of a cup per batch. If you make 6 batches, that means you've used 3 cups. You started with 8, how much do you have left, right? So there's always, usually another way to figure it out if you struggle with the linear model.